Subnetting is the process of breaking down a large network into smaller networks. So why would we want to do that? Let's take a look at an example. In our example, we have a business organization with 6 departments and a head office. Now each of these departments is going to have its own local area network with 20 computers in it. And in the head office, we will have a LAN with 30 computers in it. Since all the 6 departments and the head office will each have their own local area network, we'll have 7 local area networks altogether, and we will have a total of 150 computers. That is 20 in this, 20 computers in this local area network, 20 computers in this one, 20 here, 20 here, 20 here, and 30 here. If we add all of these up, these are going to be equal to 150. So these 150 computers are spread over 7 local area networks which are owned by a single business organization. One of the solutions we can have is that we can buy class C network addresses for our local area network. So a separate class C network for this local area network, another class C network for this local area network, another class C network for this local area network, another class C network for this local area network. So for all of these local area networks, individually for each one of these, we are going to buy a class C network. So C, class C, separate class C networks, and in total we are going to be buying 7 different class C network addresses for each one of these local area networks. Remember that class C networks are from the classful IP addressing scheme. So we are going to buy 7 class C networks because we have 7 local area networks, and each class C network is going to come with 256 hosts. Which means what? Which basically means that we can have, now we have bought 7 class C network addresses, and each one comes with 256 hosts. So this comes out to be 792. So effectively these are the number of IP addresses that we would have bought, right? Because we're going to get 7 class C network IP addresses, 7 class C network IP addresses. Each one is going to have 256 hosts. So this is the total number of hosts that we can have with 7 class C. These are the total number of hosts that we can have with 7 class C networks. So effectively we have purchased IP addresses for 1792 hosts, whereas the organization only has 150 computers, which basically means what? Which means lots of IP addresses are going to get wasted. So 1792 is the total IP addresses that we have, and we are only going to be using 150. So effectively what we're going to be left with is 1642. So these are going to be wasted. So these many IP addresses are going to be wasted. So what you can see here is that, effectively subnetting is also handling the same problem with classful IP addressing that CIDR was trying to help us with. So lots of IP addresses are getting wasted, and we don't want that to happen. So what is the solution that subnetting provides to a problem of this sort? So how can subnetting solve our problem? See, let's just try and understand this diagram first. Let us assume we've bought a single class C network address. Let us assume that the IP address that the network address that has been assigned to us is 198.88.98.0. Remember, this is the network address, so all the host bits have been set to 0, and this is a class C network. We can take a look at this starting value. Since this value is between 192 to 223, therefore this is a class C network. With this class C network address, we can have we can have 2 raised to power 8 minus 2, which is basically 254 hosts. So we can have these many hosts. What we should remember is that on a class C network we have 8 host bits. So with 8 host bits we can use this formula to determine how many hosts that we can have on this class C network. So this entire network on the right hand side will have a single class C network address, right, given by 198.88.98.0. okay, so we have a single class C network address, right, and in that single class C network address we can only have 254 hosts. And remember, in our problem we need a total of 150 computers for this business organization, such that there were going to be 20 here, 20 here, 20, 20. So each local area network for the departments was going to have 20 computers, and this one was going to have 30 computers, right? Now what we are going to do is that we are going to break this one class C network into smaller networks, and let's see how we are going to do that. We are going to use the host bits to set up our subnets. We have 8 host bits available to us, and out of these 8 bits we are going to steal 3 host bits to be used for our subnets. So we are going to take away 3 host bits to be used for our subnets. So technically this is going to be used for a subnet, this is also going to be used for a subnet, and this is also going to be used for a subnet, and the remaining bits will be used for our host bits. So the remaining bits will be used for our host addresses. So what we've done is, out of the entire 8 host bits available to us, the network administrator will steal 3 bits and will use them for our subnets. With 3 bits we can have a total of 2 raised to power 3, which is equal to 8 different subnet IDs. So these are all the possible IDs that our subnets can have. 8 different IDs. As you can see in this diagram, our head office has the subnet ID 000. LAN 1 will have the subnet ID 001. LAN 2 will have the subnet ID 010. LAN 3 will have the subnet ID 011. LAN 4 will have the subnet ID 100. LAN 5 will have the subnet ID 101, and LAN 6 will have the subnet ID 110. So each one of these LANs has a unique subnet ID: 000, 001, 010, 011, 100, 101, and 110. So each one of these LANs has a separate unique subnet ID. Let us assume our router receives a message from the internet to be delivered to the IP address 198.88.98.11. So from the internet, a router receives a packet with the destination IP address 198.88.98.11. So which one of the subnets will the router forward this packet to? As you can see, we have 8 subnets on the right hand side. So where is this packet going to go? On which subnet is this packet going to go? Basically, which subnet has the computer with the IP address 198.88.98.11? To find that out, let me write the value of our last octet. This last octet. So let me write the value of this last octet in binary form. So the last 8 bits, which are basically the host bits in a class C network, have been written down in binary form. But as you can see, out of these 8 bits, we are using the first 3 bits for the subnet ID, and the subnet bits in this case are 0, 0, 0. So these are 0, 0, 0, which means that this host is present on the subnet with subnet ID 0, 0, 0. And as we can see in our diagram, that that 0, 0, 0 is the subnet ID of our head office local area network. Remember, this subnet ID was configured by the network administrator on the router using software. So the router is now going to forward this message onto the local area network for the head office, onto the subnet for the head office LAN. So now that we have 3 bits being used for the subnet, we are basically left with 5 bits for the host. So the first 3 bits are always going to be used to identify the subnet, and the last 5 bits will be used to identify a host on the subnet. So these 5 bits will always be used to identify a host. So these are going to be used to identify a host, and these will be used to identify a subnet. So these will be used to identify a subnet. Okay, now the question is, how many hosts can we have on a subnet in this example? Well, we have 5 host bits, which means for these 5 host bits we can have 2 raised to power 5 minus 2, which comes out to be 30. So we can have 30 hosts on a subnet. Remember, these are being used for the subnet and these are being used for the host address. So we have 5 bits for the host address. So using our formula 2 raised to power 5 minus 2, we'll get 30 hosts on a subnet. So basically all the 7 subnets in this example are going to have 30 hosts each. Now this fulfills our requirement perfectly. Here is what we have done. We've used one class C network address. We have broken that class C network address into smaller networks, and we've called those smaller networks as subnets. To the outside world on the internet, it appears to be a single class C network. So this appears to be a single class C network. If we are looking from this side, all of this seems to be a single class C network, but internally we have broken it down into smaller subnets. So on this side of the router, we've broken it down into smaller subnets, but on this side, when we are taking a look from the internet, this appears to be a single class C network. Okay, let's take a look at what happens if a router receives a packet with destination IP address set to 198.88.98.157. Let us quickly convert the last octet 157, this last octet 157, to its binary form. As we can see that when we convert 157 into its binary form, it equals 1001101. So this is what it equals, right? And we can also see that the first 3 subnet bits take the value 100, which basically means that this destination IP address 198.88.98.157 resides on the subnet with the subnet ID 100 right here. Okay, so the router will forward this message onto the subnet with subnet ID 100. So this is the link on which the router is going to forward this packet. Okay, let us do another example of subnetting. In this example, the organization has 4 departments, and each department is to have its own separate local area network. Each department will have 50 workstations approximately. how can we use subnetting in this scenario? So this is what we want. We want to buy a single class C network address. So we want to buy a class C network address, and let us assume that the address that we've bought is 202.100.50.0. So this is the class C network address that we've purchased. And now internally on our router on this side, we are going to break this class C address into 4 subnets, such that this is going to be a separate subnet, this is going to be a separate small local area network, this is going to be another local area network, and this is going to be another local area network. This is a class C network address. So we have 8 host bits available to us. Out of these 8 host bits, we are going to use only 2 bits, the first 2 bits for our subnet ID. So we are only going to be using 2 bits for our subnet ID. We are only going to be using 2 bits because with 2 bits we can have 4 unique IDs, right? 2 raised to power 2 is equal to 4, and we can have 0 0 0 1 1 0 and 1 1. So these are the 4 unique subnet IDs that we can have with 2 bits, and because we only need 4 subnets, so therefore we can use 2 bits. We can use the first 2 bits to represent our subnet. So the network administrator configures with the help of software each subnet with a subnet ID. So let's assume that this one gets the subnet ID 00, this one will have 01, 10 and 11. So all of these 4 subnet IDs have been assigned to our subnets. So now that the subnet IDs have been assigned, let's see what happens when this router receives a packet from the internet with the destination IP address set to 202.100.50.204. Let's see what happens. Because this is a class C address and the last octet represents the host bits, so this last octet, it represents the host bits, right? I'm going to write this last octet 204 in binary form, and 204 in binary equals 11001100. Since we are using the first 2 bits to represent the subnet, therefore our subnet ID in this case is 11, which means the router will forward this packet received on this link. So what if the router receives another packet from the internet with the destination IP address set to 202.100.50.130? Okay, the first thing I'm going to do is I'm going to convert this last octet into its binary form. In binary form, 130 equals 100000010, and as we can see that our subnet bits in this case, our subnet bits are 10. So these are our subnet bits, and the subnet ID is 10. This is the subnet ID. So this packet will be forwarded by the router on this link to LAN 3.